Okay, hi, Assalamualaikum warahmatullahi wabarakatuh. Okay, my name is Yusrina binti Yusof. My metric numbers is 1160242. Okay, so today I present the journal on the topic investigation of the ionic conduction mechanism in carboxymethyl cellulose or cytosine bipolymer blend electrolyte impregnated with ammonium nitrate. Okay, so basically this journal is written by M.S. A. Rani, N.S. Mohammed and Min Isa. Okay, so as we know, carboxymethyl electrolyte, carboxymethyl cellulose, or we known as CMC, is one of natural polymer. Okay, so nowadays we know that natural polymer is good, right? So many researchers had done many research on this CMC. So solid proton conducting polymer electrolyte had attract many attention due to its potential applications in producing sensors, fuel cells, supercapacitor and rechargeable batteries. So it is different. CMC or natural polymer is different compared with the liquid electrolyte because solid polymer electrolyte, or we known as SPE, have dynamic properties such as satisfactory mechanical properties, good shelf life and no leakage. And so to reduce cost and use biodegradable material to save the environment, so basically many researchers have investigated the potential of these natural polymers in becoming a good solid polymer electrolyte. Okay, so this experimental section, the method of the method of this research. Okay, so the solution casting technique was employed to obtain films with varied amount of ammonium nitrate concentration from 10 until 50 weight percent. Okay, so pure NBE film. Okay, NBE stand for natural bipolymer blend electrolyte. NBE natural bipolymer blend electrolyte. Film without dopant was also prepared as a control. So in a clean beaker with amount of CMC and CS powder with ratio 2:1 with ammonium nitrate crystal were dissolved in 100 milliliter of 1% acetic acid at room temperature. Okay, so complete dissolved solution. Complete dissolution was achieved after 24 hours of stirring at room temperature using the mixture. The final light yellowish solution was then poured into separate petri dish and left to dry in an oven to form yellowish transparent thin film. So the NBE films were transferred to a desiccator for further drying pure to characterization. The impedance study was performed by using a Hioki and impedance spectroscopic measurement was performed to determine the ionic conductivity of bipolymer electrolyte films over the temperature range from 30 to 100. And then the last one is the bipolymer electrolyte samples were sandwiched between stainless steel electrodes that have a surface contract area of 2 cm squared, and the samples were mounted onto the solution holder under spring pressure. Okay, so basically from the result of this experiment, when the temperature increase, the ionic conductivity increase, because the enhancements of the conductivity with temperature can be explained by the decrease in viscosity and thus increase in polymer chain flexibility. So the ionic conductivity also increased due to the increase of the salt solution. So when the salt solution increase, the ionic conductivity increase. So the conductivity increase upon addition of 10 up to 40 weightage percent of ammonium nitrate. So the maximum ionic conductivity achieved in 1.03 exponent 5 cm -1 per Siemens per centimeter. The increase of ionic conductivity with addition of ammonium nitrate concentration is due to the increase of the number of charge carriers and mobility of ions or conducting species. However, the conductivity dramatically declines after addition of the 40 weightage percent of ammonium nitrate. And Ng and Muhammad reported that as ammonium nitrate concentration increased, the host matrix polymer blend become crowded with the dopant ion. So because of that lah, the conductivity declines. So Ng and Muhammad this report also get from the journal of from the Ng and Muhammad journal. Okay, so the conclusion, CMC or CS natural bipolymer blend electrolyte incorporated with ammonium nitrate was successfully prepared. Sample increase successfully prepared using the solution casting technique. So the ionic conductivity of the prepared sample increased with addition of ammonium nitrate concentration as well as the temperature lah. Okay, so the maximum conductivity value of 5.77 exponent -5 Siemens per centimeter was obtained for the system containing 40 weightage percent of the ammonium nitrate at the ambient temperature. So variance in conductivity with temperature show that all electrolytes okay, so variation conductivity of conductivity with temperature show that all electrolytes follow the Arrhenius rule. And the variation of conductivity in this system was due to the variation of concentration and mobility of the ion. The conduction mechanism for the system with 40 weightage percent of ammonium nitrate was best represented by the CBH model. Okay, that's all from me. Thank you.